We are Group 1 for the Hydraulics project. In this video, we will go over the topic of differential pressure flow meters. My name is Brent, and my partners are Brian and Brandon. In this video, we will show a video that briefly describes the basic principles and components of the differential pressure flow meter. Then we will discuss how Bernoulli's equation and principle apply to that idea. Next, Brian and Brandon will discuss each main type of differential pressure flow meter and how they work. And finally, we will provide you with important takeaways that could help you with questions on the upcoming exam. Now our video will play.
Flow measurements are essential to running a plant efficiently and safely. There is an array of flow measurement technologies available, including differential pressure flow, also known as DP flow, which utilizes a variety of measurement instruments. DP flow is measured with a combination of a primary element and a secondary element. A primary element is placed in the pipe to create a differential pressure while connecting the secondary element to the process. The secondary element, or transmitter, takes measurements from the primary element and converts them into useful quantitative values and transmits those values to a control system. There are many types of primary elements, including traditional orifice plate, cone, venturi, nozzle, wedge, Rosemount Annubar averaging pitot tube, and Rosemount conditioning orifice plate. Primary element selection is dependent on process conditions. All of these different primary elements have one thing in common. They constrict the flow in a pipe, causing a pressure drop from one side to the other. The difference in pressures is the differential pressure. The square root of dP is proportional to the flow rate. Traditionally, transmitters were connected to the process with external impulse piping. Impulse piping is a major expense and gives opportunities for multiple leaks and creates unnecessary safety hazards by adding extra valves and manifolds to the process connection. Now, with new and improved primary elements, the impulse piping is built into the primary element. This allows the transmitter to be directly mounted to the isolate and equalize valves, resulting in an integrated flow meter. The built-in piping is factory leak checked, makes installation easier, and reduces maintenance costs. The impulse piping of the integrated flow meter runs from the process through the primary element to the sensing diaphragm of the transmitter. On one side of the transmitter is the high pressure side, on the other, the low pressure side. The diaphragm deflects relative to the pressure change from one side to the other. It is very sensitive and can detect very small changes in pressure.
Hi, my name is Brian Needham, and I will be talking to you about how the Bernoulli's equation relates to differential flow meters as well as orifice meters and venturi meters. Bernoulli's equation is used with differential pressure flow meters to measure the flow of fluid in a pipe. We derive from the Bernoulli equation that a difference in velocity creates a difference in pressure. For horizontal flow, an increase in a fluid's velocity must result in a decrease in pressure. Therefore, the velocity or discharge of a fluid system can be determined by measuring the change in pressure. The differential flow meters constrict the pipe in a certain spot along the run, creating a pressure drop throughout the flow meter. As the flow increases, more pressure drop is created. By measuring the pressure drop over a constriction, the flow rate is able to be calculated. Bernoulli's equation states that the pressure drop across the constriction is proportional to the square of the flow rate. An orifice plate flow meter is a flat plate with a hole in the center that is placed in between flanges in a pipeline across the flow of a liquid. The pressure difference generated by the flow velocity through the hole enables the flow quantity to be measured. These meters measure gas, liquid, or steam in commercial or industrial situations. Advantages of the orifice plate flow meter are that they are easily fitted between flanges and have a simple construction. There are also no moving parts, and the meters are well understood and proven. Some disadvantages are that orifice meters require straight pipes to ensure accuracy, and the pipeline must be full for liquid flow measurements. A venturi flow meter is a flow measurement instrument which uses a converging section of pipe to give an increase in the flow velocity and a corresponding pressure drop from which the flow rate can be deduced. These meters can be used in dirty streams because there is no buildup of foreign material. They can be constructed to be either gas flow meters or liquid flow meters. The pressure recovery is much better for venturi meters than for orifice plates. Some of the advantages for the venturi meters are that they have less chance of becoming clogged with sediments, the behavior can be perfectly predicted, and they are able to be installed vertically, horizontally, or inclined. Some disadvantages are that they have an expensive initial cost, they are large in size, and maintenance of the meters is not easy.
Hello everyone, I'm Brandon Wypasic, and I'm going to talk about two other of the DP flow meters that we did our project on. One is the wedge flow meter and the other is the V-cone flow meter. A wedge flow meter is a wedge-shaped element that is perpendicular to the flow at the top of the conduit, which means that the bottom part is unrestricted. This basic operating principle behind wedge meters is straightforward. A V-shaped restrictor in the flow meter body reduces the available flow area, constricting the flow. This constriction increases the fluid velocity, causing a corresponding increase in the kinetic energy of the fluid being measured. A differential pressure transmitter is used to measure pressure between either sides of the wedge. However, this type of differential pressure flow meter technology can be constructed to work as either a gas or a liquid flow meter. Wedge flow meters are highly robust and resistant to wear. They offer the solution to measuring dirty, vicious, or abrasive flows, as well as those where there is a risk of fouling. This enables them to be used in applications which could quickly render other types of DP flow meters useless. The second DP flow meter I'm going to talk about is the V-cone flow meter. A V-cone flow meter consists of a V-shaped cone element placed at the center of the pipe, which creates an annular space of the passage of fluid. The principal theory among a V-cone flow meter is Bernoulli's theorem for the conservation of energy in a closed pipe, which states that for a constant flow, the pressure in a pipe is inversely proportional to the square of the velocity in the pipe. V-cone flow meters have lower permanent pressure loss than an orifice flow meter. The cone element conditions the flow at the same time it is creating the pressure differential, providing for smoother and less noisy differential pressure readings versus the orifice technology. A differential pressure transmitter is used to measure pressure before and after the cone. This type of can be constructed to measure gases, liquids, or stream. Some advantages for a V-cone flow meter include the ability of the V-cone meter to operate with very short upstream and downstream straight pipe lengths, to create a low total pressure or head loss, to create a very stable DP, to create relatively low signal noise, and to cone well with liquid and particulates in the gas stream. Some important takeaways from our presentation: wink wink. The purpose of a differential pressure flow meter is to change the pressure. The most simplistic way to do so is to change the volume of the pipe. 2. Bernoulli's equation states how the pressure will change as the volume of the pipe changes. 3. Differential pressure flow meters account for almost a quarter of the world market for flow meters. 4. As a result of the differential pressure flow meter, there is some energy that is lost through the process to other forms. And finally, 5. Different types of differential pressure flow meters cause a varying amount of permanent pressure loss. I hope you guys enjoyed our presentation.
My 20 years here at University of Akron, that's the best presentation I've ever seen.